Ravit, go for
For
it.
sure. Awesome. So our next speaker is Salma Bakog. She is the CEO and co-founder of Sifle, a full data stack observability platform. Before Sifle, Salma was an executive director at Goldman Sachs in sales and trading in Asia, where she led key data and analytics initiatives. Sifle is a full data stack platform, as I mentioned, delivering actionable insights to data engineers and data consumers. Salma will be talking about the future of data reliability. I'm super excited about it. So without any further ado, let's have Salma up here.
All right. Salma, welcome to the Modern Data Fest virtual stage. Glad to have you
Hi.
here.
I'm very happy to be here.
I see your slides now, so we're all good. My computer had a little
Awesome.
glitch where you disappeared, and now you're back. So glad you're here.
Good.
And where are you tuning in from?
Yeah. Oh, I'm in Berlin. I was here, with the team for the Berlin Data and AI Summit.
Oh, nice.
Wow.
What time is it for you now? It's pretty late, huh?
It's 7 p.m.
Okay. I guess not as late as for Ravit. So Ravit's a trooper here. So
yeah.
All right, we won't take up much of your time. So you've got about 10 minutes to do your presentation. We'll be back for some live Q&A. Really looking forward to your talk.
Awesome. Great. Thank you, Kate. All right. Hello, everyone. Okay, here are my slides. Hi, everyone. So for people who don't know me or Sifle, I'm Salma, I'm CEO and co-founder here at Sifle. Sifle is a data reliability, data quality management solution. We kind of have a different approach in the sense that we are full stack observability tool, and I can go into what that means in more detail in a bit. So when Ravit and Kate approached me to speak at Modern Data Fest, and they suggested that I speak about the future of data reliability, my initial reaction was, wait, I don't hold a crystal ball, so I can't really make any big statements there. But I'm fortunate enough to be building a company in this space, and so I guess I can at least share some insights from my vantage points and from what we see is shaping the category over here at Sifle. So let's get started. I hope everyone sees my screen. So we're gonna talk a little bit about what happened and what shaped the data engineering space in general over the past few years. It's, first of all, data engineering is a constantly evolving field, and I feel like in general the definition of it and the expectations around data in general from organizations is a forever moving target, and what it means depends really on the stage of both the business and the data maturity of the organization. But I feel like if we want to make some general statements and describe what happened in the data engineering space over the past decade or so, the emergence of a whole plethora of new technologies in the space have kind of shaped the data engineering, the role of the data engineer, as well as the expectations around data, and made, in general, the processes a bit more smoother and a bit more automated. So when data engineering first emerged as a job or as a responsibility, a lot of companies were struggling with very simple problems, but that were quite challenging at the time, which is how are we going to transform raw data into insights and things that make sense for the business, right? So a lot of the job of the data engineer was centered around building infrastructure, building pipelines, making sure that there is enough processes in place that can move data from A to B, point A to point B, and really trying to create a whole infrastructure that could support what the company was trying to achieve with data. Now, obviously, when you are building things from scratch, when you are using a lot of manual processes, when there's a lot of coding involved to create, pipelines and transform the data, model the data, etc., things can break, and inevitably you end up in a situation where you're constantly firefighting problems, right? And so the first or the most natural reaction for data practitioners is to start looking at what other adjacent categories have done over the past few years, and more mature categories, and the closest one is software engineering. So implementing testing the pipelines, implementing checks at the data level, and stuff like that is kind of a natural progression to achieve a certain level of reliability of the data assets, and have a preliminary data quality framework. Now, if we look at the presence of the data stack or the data engineering space in general, the whole revolution that took place and that's led to the creation of a lot of technologies over the past decade or so helped automate a lot of the processes for data engineers. And in each compartment of the data stack, you'll have a variety of mature hosted solutions that can help make the life of data engineers a little bit easier and help them manage the complexity of the data platform at scale. Now, this is what you see in my slide is a pretty simplified version of the data stack, but in reality, in most organizations, the data stack looks like something like this. So what do you do when the complexity of the platform keeps increasing, the expectations of the stakeholders keep increasing, and the expectations from the overall or the expectations around the data team in general keep increasing and keep on changing and evolving with time? So when you, as I mentioned earlier, when you initially start with data quality, the initial reaction or the initial the natural thing to start with is to start implementing testing and basic anomaly detection. This is a good place to start, and there is a lot of open source solutions that can help getting started with data quality, getting started with quality checks, testing the pipelines, etc. But the problem with this approach is, first of all, it can be extremely manual. It needs a lot of time to set up, does not scale well, etc. The second biggest problem that we've seen working with hundreds of companies of various sizes and from previous experience as a data practitioner is that you end up in a situation where you get so many alerts about so many random things breaking all the time that you get to a point where you just start to ignore the alerts and you get to a point of alert fatigue, which can be extremely dangerous because that one time you're gonna ignore an alert, it's likely going to result into something very disastrous for the business. Another challenge to this approach is that it favors, or it kind of increases or makes the presence of silos and the lack of ownership a bit more accentuated, in the sense that everybody's throwing the ball around data quality. Like, is it the responsibility of data engineers? Is it the responsibility of data product managers? Is it the responsibility of the data consumer? And more often than not, this leads to a dilution of what the company sets as objective as far as data quality and data governance go. Now, in preparation for this talk, I had a pretty existential discussion with my team because, and without taking this into a vendor push, because we as Sifflé have created industry's first and only full data stack observability platform, in the sense that we cover everything that can go wrong at the data, metadata, and infrastructure layer. Now, the question that I got from my team preparing for this is, okay, is this the present of data reliability, or is this the future of data reliability? the thing is, data observability as a category in general is relatively new, and there's a lot of different approaches that have emerged, and it's only a matter of really leaving it to the end user to decide what kind of expectations they have from the data and how they want to define data quality and data reliability. So for the sake of today's presentation, we're going to focus on the full data stack observability approach, and what I think is where the industry overall is headed, because we are definitely getting to a point where companies want to embrace the complexity in the data infrastructure. They want to leverage data to its maximum potential. They want to create more use cases. They want to start using ML to get better and smarter about the way they make decisions. And so really the constant in all of this is that the complexity is only going to increase. And so now the question for data practitioners becomes, okay, how do I embrace that complexity? How do I navigate that complexity? Because it does offer me flexibility to an extent. How do I navigate that and take the best advantage I can from data and from the flexibility that the data infrastructure is offering me? And the answer to that is full data stack observability. Now, what is full data stack observability? Let's first define data observability. So data observability is really, again, it's a new category, but the way we define it is a collection of signals and metrics that can help both data producers and data consumers get an idea about the health status of the data assets. Concretely speaking, how does that look like? So if, say, you have a data stack, you have your ingestion tool, you have your transformation orchestration layer, so you have the transformation layer, you have a data warehouse, you use BI for some analytics, you use a reverse ETL because you want to take further advantage and loop the data back to the business. You use some ML use cases that you know your machine learning engineering teams or your data scientists are working on, etc. You want observability to help you achieve trust in the data and in the infrastructure that supports data at any stage of the data pipeline and at any stage of the data workflow. So if we use the definition full data stack, and this is where our approach comes into the picture, Cflare, for example, is a top of stack layer. We sit on top of your existing data stack, your favorite tools that you've already used and trust. And we collect signals at the data, metadata, and infrastructure level to ensure that if something breaks, we let you know. And if something breaks, we let you know for sure. But more importantly, we give you the insights on how to fix it and how it's likely to impact the business. If we look at the anomaly detection part specifically, and this is, I think, where the line is drawn between what's done in the present and what's going to be the future of data reliability in general, you definitely want to look at anomalies that impact the metadata, right? Like that's, I guess, what most people start with when they start using data in an organization. You want to look at whether you're ingesting the right number of rows. You want to look at the distribution of your data. You want to look at schema changes and get ahead of them. You want to look at the volume of your data, etc. But you also want to look at anomalies at the data level, or you want to detect anomalies with the data itself. So say, for example, you're an e-commerce platform, it's Black Friday, sales are happening, but you want to make sure that there's, you know, the prices that are being published on your e-commerce websites are actually accurate. Say, for example, you know, there is a logic that the price should never be negative, or the price should never be, you know, below a certain level, or stuff like that. Or say, for example, you're working on a machine learning model that's going to be trained on a set of data about certain demographics. So you want to make sure that you're getting zip codes in the right format. You may want to make sure that you're getting email addresses in the right format, etc. So in your data quality framework or in your data observability framework, you definitely want to also include metrics about the data itself. Now, and this is where I think we're going to be moving towards in the future, is really the concept of the reliability of the infrastructure supporting the data and how you can take it even a step further and look at things like efficiency of the platform, performance of the pipelines, performance of the applications that are supporting the data assets, and really have a better understanding of how different applications are connected to each other and how it is likely to cause data quality issues, if at all. And for that, for example, there's different approaches to go about it, and the idea is not to recreate what's been done in the software engineering space, but really to adapt it to the data and data infrastructure, and get ahead of data quality issues before they even become or before they become business issues. So that's the high level approach. I'll be happy to take this into more detail if anybody's interested offline. And I think we can call Kate and Ravid back to the stage so they can ask some questions.
Awesome.
Hello.
This is great. Yeah,
Thank you.
Great information about data observability, full stack observability. Salma, we're a fan. At least I've heard a lot about full stack data observability from you. And I'll let Kate ask questions. I know for a fact I've already asked you a few questions earlier, but Kate?
Yes, absolutely. First of all, amazing presentation. I love the slide that had like all the companies. I think that's when you said the full modern data stack looks like this. It looks kind of crazy. I don't know how people
are. We think it looks like this, but in reality, it's a bit more chaotic than that.
Yeah, let me show it one more time here. Yeah, this. So that's the present, right? I think there was another one that looked a bit more chaotic than that.
Just right after that one.
Yes. Oh, I can even move your slides. Awesome. Yeah, this one.
Exactly.
This is the one that like, how do companies navigate this? Because that's a lot.
Yeah. And you know what? A lot of companies think that simplicity is what's going to help them get a better grasp of their data assets, and it's true, right? In reality, it's true. In theory, it's true, but it's so unrealistic, and especially as the company scales and as you onboard new use cases, as you start to collect more and more data externally, it just becomes impossible to keep track of where everything is going.
Yes, and my follow-up question is, how do you actually get business buy-in, or how do you convince business leaders that data observability is important and that they need to do that?
Yeah, that's a really good question. There is a question that I always ask our prospects is, when was the last time that you had a data quality issue? Or when was the last time somebody from the business called you questioning a number on a dashboard?
Right.
And it's really a matter of trying to explain things in their own language, because if you go and ask a data engineer or a data practitioner whether they suffer from data quality issues, for sure they will say yes, right?
Of course.
But in order to get buy-in from the business, you need to explain and plead your case in wording and in language that makes sense to them, right? So you can start with something like, do you feel like you overall trust the data products that are produced by the data team? Do you feel like, are you happy with what we've been delivering in terms of dashboards? Do you feel like we could do something different? And in most cases, it's a matter of just trying to speak their own language and pointing them into direction that makes sense. Another way to do this is obviously to try to compute a potential return on investment of a data observability tool. So say, for example, if your team is taking too long to produce data products, if your team is spending too much time troubleshooting data pipelines, stuff like that, you can actually put numbers in that on that and present it to the business. And finally, and this is more of like a carrot versus stick approach. Finally, unfortunately, there's been a lot of highly publicized data catastrophes, and you can just use those as a reference. Right?
That's true. Data catastrophes is what we call them, right?
I love it.
Someone else coined that one. I forgot who, but they were on my show. We called the show Data Catastrophe, so that was fun. Ravi, you want to take a couple questions from the audience before we wrap?
Yeah, 100%. One that I'll pick from the audience and very quick. I like that question. Yeah, by Fernando. Very easy question. What does CIFLA mean?
I think we get this question all the time. I think we need to add like a frequently asked questions on our website where we define sifflet. Sifflet means whistle in French.
Whistle.
So that's the alerting part in the tool, because we do send alerts when something breaks.
Okay, that makes sense. That's a good one.
Awesome. And one last question that I had for you, Salma, was what is the biggest gap in data observability today? How do you think it will be filled in the future?
Oh, that's a really good question. I think, and again, this is a relatively new category, and I met Sanjeev in person in London, which was a big moment.
Wow.
For me, I'm a big fan of his work. And we had a discussion about this, and you know, it's interesting to pick his brain on where he sees the gap as like somebody from the outside, because I can tell you, this is what we do, this is where I think we're going. But I think it's important to talk to somebody from the outside to also understand how the market is perceiving this new and evolving category and where the consensus is headed. Obviously, I'm biased, so I do think that the full stack approach is the approach that makes the most sense. But also, you know, it's as the category is gaining in maturity, so are the expectations from the users of data observability tools, right? Maybe in the past few years, people were just okay with getting alerts when something breaks inside of the warehouse. But especially now and in the current economic environment where everybody's downsizing the teams, everybody's looking to be extremely data driven. You can't just get away with just monitoring data that's in the warehouse. Like, you need to cover all of your data assets, and you need to think about things like pipeline usability. You need to think about cost. You need to think about you know, how are your resources allocated. So I definitely think that the market is going to converge towards a full stack approach that really can answer any question you may have about data and get ahead of any data catastrophes.
We're going to watch this 5 years from now and see if your crystal ball prediction is correct. Salma, thank you so much for your time. Amazing presentation. And thank you to the audience. Great questions. Keep them coming. We have our final speaker. Thank you, Salma.